Okay, welcome back. 4.3 Trigonometric Ratios, Part 2. Determining the exact value of trig ratios given an angle. Okay. Example 1. Determine the exact value of each trig ratio. Do not use your calculator. Cosine of 315 degrees. So if I draw my axes here, and I go 350 degrees, so from my initial arm all the way through, that's going to put me right in the middle of quadrant 4. So theta equals 315 degrees. What's the exact value? Okay, so in quadrant 4, the exact value of cosine of 315. Okay. What's that reference angle? The reference angle here is 45 degrees. And I know the angle is 45 degrees, so that value, cosine of 315, that value for a reference angle of 45 degrees is square root of 2 over 2. Okay, and it's a cosine value in quadrant 4, so that's why it is positive. Okay, tangent of pi over 2. So I start here, initial arm, I sweep all the way up. There's pi over 2 radians. Okay, that's also my reference angle. Okay. What is tangent of pi over 2? What is that ratio? Well, let's take a look at it in terms of sine of pi over 2. Okay, that is 1. What's the cosine of pi over 2? That is equal to 0. 1 divided by 0, that's undefined. Okay, so tangent of pi over 2, this is undefined. Next one, sine of 11 pi over 4. So I make my axes here. And then I go, if I think 12 pi over 4, that's 3 half rotations. But 11 pi over 4 is pi over 4 short of 3 half rotations. So I go, that's pi rotations, or 4 pi over 4, 8 pi over 4. And then I'm going to go to 11 pi over 4. I'm going to stop here. So that is, I can read that reference angle right here. That's going to be pi over 4, right? And the sine value is the y value. So sine of 11 pi over 4 is square root of 2 over 2. This is in quadrant 2, and we expect sine to be a positive value. So there you go. Oops. Next one, cosecant of 7 pi over 6 plus cosine squared of pi over 4. Ooh. Okay. First, let's think of it this way. I'm going to sketch out 2 different graphs here. Cosecant of 7 pi over 6. First, let's do 7 pi over 6. So I start with my initial arm. That's pi over 6. And then I need 7 pi over, sorry, this is 6 pi over 6 up to here. Then I need another pi over 6, and it lands me right there. So this theta r value is pi over 6. Okay, so theta r value is pi over 6. If I look at this, the cosecant is 1 over the sine of 7 pi over 6. It's a reciprocal identity. So that's 1 over, well, for a theta r value, reference angle of pi over 6 in quadrant 3, right? What is that y value? That's negative 1/2. Okay, so the cosecant of 7 pi over 6 equals negative 2. Okay, let's hold that one. We're going to do part 2 here. Cosine squared of pi over 4. Ooh, let me just, the detail here. Notation wise, it's the same as saying cosine of pi over 4, all of it squared. So this is the same notation as this. Okay, so when I sketch this out, I'm just going to look at pi over 4. Well, cosine of pi over 4 just takes me halfway through quadrant 1. So theta r equals pi over 4. Okay, And then, so what's the cosine value there? It's square root of 2 over 2. So cosine of pi over 4 is square root of 2 over 2. Okay, so when I do this last part, I'll do it in blue here. Cosecant of 7 pi over 6 plus cosine squared of pi over 4, that is negative 2, plus square root of 2 over 2 squared, that's 4, plus, oops, sorry, oh man, that is negative 2 plus 1/2, and that equals negative 3/2. Okay. Last one, sine of negative 300 degrees minus cosine of 150 degrees. Okay, first one, I'll do the sine of negative 300. We're going clockwise, folks. Remember, it's a negative angle, so I'm going clockwise. I'll go 90, 180, 270, and then 30 more for negative 300. So it ends up right here. Okay. Well, what is this theta r value? This theta r value is 60 degrees. So this is for a theta value of negative 300 degrees. Okay, so theta r is 60 degrees. So sine of negative 300 what's the y value, right? So for a reference angle of 60 degrees, that is square root of 3 over 2. Okay, the other one, let's do both of these. So I'm going to bookmark this right here. The other one, I have cosine of 150 degrees. So I start, this is a positive angle, so I'm going to go counterclockwise. 150 degrees will take me 30 degrees short of 180 right here. So my reference angle, theta r, that is 30 degrees. Okay, so what's the cosine value for a reference angle of 30 degrees? Well, it's negative square root of 3 over 2. So the cosine of 150 degrees, cannot forget my degree sign here, is negative square root of 3 over 2. And then so sine of negative 300 minus cosine of 150 degrees. I keep forgetting the degree sign. Negative 300 degrees. There we go. That is square root of 3 over 2 minus negative square root of 3 over 2. That is 2 square root of 3 over 2, and that is square root of 3. Okay, determining an angle given an approximated trig ratio. Okay, first, let's take a look at the right here. It says determine the reference angle using the absolute value of the ratio and the inverse function on the calculator. Pay attention to whether you need degree mode or radian mode. This is very important. This is also very important. If you just punch a value straight into a calculator, the calculator will give you one value, but it won't consider where that value exists in the different quadrants. So remember, so for example, like a negative cosine value, so if you have a ratio, if you have a cosine ratio that is negative, well, what quadrant could that be in? Right? That could be in either quadrant 2 or 3, but the calculator won't tell you the angle for both of those quadrants. It'll only tell you one of them, right? So that's why you need to do the absolute value. Okay, find the reference angle, use cast to determine which quadrants that the angle must terminate in, and then draw your coordinate axes and draw out the angle using reference angle rules, and then figure out like where the angle exists. Okay, let's do a couple examples. Also check your domain. So I'm going to give you different domains to keep you on your toes to see where does this exist. Okay, solve cosine of theta equals 0.843 in each given domain. Round all answers to the nearest tenth of a degree. So remember to use absolute value here. So cosine of theta equals 0.843. So just get into the habit. Theta r equals inverse cosine. So we need that angle. the absolute value of 0.843. Okay, use that inverse cosine value there. So this is in degrees, so you want to be in degree mode. So I get 32.5417 degrees. Okay, and then draw your coordinate axes for a reference angle of 32.5417 degrees, right? I said cosine of theta is greater than 0, and that's in quadrant 1 and quadrant 4. Okay, so in quadrant 1, the angle is just 32 let's round to the nearest 10, 32.5 degrees. In quadrant 4, we have to be mindful, it's 360 degrees minus theta r, right? So remember, we're doing up to here. Okay, 360 degrees minus 32.5417, and that equals a theta value, angle and standard position, of 327.5 degrees. So your solutions are two of them actually, solving for theta, right? So we're determining an angle. So essentially we're solving a trigonometric equation, a very basic one. Okay, so theta can equal 32.5 degrees or 327.5 degrees. And to make sure, is it within the domain? Yes, it is. Okay, let's do another example. Again, make sure your calculator's in degree mode. This time, negative 360 to 180 is my domain. Okay, we're using the same trig ratio, right? We're using the same one. This is just part 2. Quadrant 1, theta equals 32.5 degrees, right? Still the same, right? So quadrant 1, this is the same solution from before, and that's within our domain. Okay, the other part, right, I can't use this anymore because that's outside of our domain. Our domain only goes up to 180, but I need to think in terms of negative angles as well. So if I start here, okay, and I go negative 32.5, well, my angle in standard position is negative 32.5 degrees. So this one has two solutions again, but they're not the same as the previous example because I have a modified domain. And this negative 32.5 is definitely within the domain. Okay, and then if you try to pick a coterminal angle to this by adding negative 360 degrees, it will fall outside of this domain. So we know that these two are the only two solutions. Next page. Okay, solve. Oh, hang on. So we're at A, B, and then C. Solve sine of negative 0.879 in the domain 0, theta is greater than or equal to 0, less than 2 pi. Round all answers to the nearest tenth of a radian. Okay, so let's take a look at this. So first I need to find the reference angle. So theta r equals the inverse sine of the absolute value of negative 0.879. Okay, radian mode, don't forget radians. Okay, so let's do inverse sine of the absolute value of negative 0.879. I get a theta r, or reference angle, of 1. 1.0737 radians. Okay. Okay, if you don't use the absolute value and you do inverse sine of negative 0.879, you forget that, you get a totally different radian value. You get the negative of that. You get negative 1.0737 radians. So you want to do the reference angle first, okay? And then you want to look at each case based on the sign of the angle that we're dealing with, right? Or sign of the ratio, sorry, the positive or negative sign. Okay, so I have a reference angle of 1.0737 radians. Okay, where is the sign value negative, right? Sine of theta is less than 0 in quadrant, so CAST. So not in quadrant 1, not in quadrant 2. It's in quadrant 3 and 4. So quadrant 3, quadrant 4. So we need to draw cases for both quadrant 3 and 4. So let's quadrant 3. Okay. In quadrant 3, 1.0737 radians looks like this, right? So somewhere about there, that's theta r, 1.0737 radians. Okay. So in quadrant 3, I need to take pi and add it to my reference angle to get the angle in standard position. Okay, so that is round to the nearest tenth of a radian, that is 4.2 radians. Okay, another case, quadrant 4. Okay, quadrant 4, 1.0737 radians. So somewhere over here, this is theta r, 1.0737 radians. Well, in quadrant 4, I'm doing 2 pi minus 1.0737 radians, and I get 5.2 radians. Okay, before we move on, let me sketch it out. So this one, 4.2 radians, what does that look like? That's the angle in standard position. So I start initial arm, sweep all the way through. This is my angle in standard position, 4.2 radians. Initial arm, sweep it all the way through. This is my angle in standard position, 5.2 radians. Okay. Okay, you try. Secant of theta equals negative 1.046. For theta is an element of, we got some interval notation, negative 180 degrees to positive 180 degrees. Okay. Round all answers to the nearest degree. Okay, so pause it here, give it a try. Okay, I'm going to think of it this way, right? That's 1 over negative 1.046. So I'm going to make an equivalent statement with a cosine of theta because I don't have secant button on my calculator, right? So this, folks, cosine of theta equals negative 0.956. And then so I'm going to find the reference angle, cosine, inverse cosine. Remember, it's the absolute value of negative 0.956. And then my theta r value equals 17.0551 degrees. Let's see what quadrant we're in. Cosine of theta is less than 0. And we know that is in quadrant 2 and quadrant 3. So cosine of theta is negative in quadrant 2 and quadrant. Remember, we're doing this for the secant ratio, but we don't have a button for secant ratio. That's why I converted to a cosine ratio by using this identity. Okay. All right. So let's map it out. Quadrant 2. Okay. I start initial arm. Oops. No, 17.055 degrees, right, in quadrant 2. So sorry about that, folks. In quadrant 2, so this is my theta r. So in quadrant 2, that's 180 degrees minus 17.0551 degrees. And that is nearest degree, 163 degrees. Okay, quadrant 3, we said quadrant 3, so theta r would be here. Okay, notice our domain here. It says negative 180 to positive 180 degrees. If I go this way, that's over positive 180. So I can't go this way. Well, hint, hint, I'm going to go the negative direction. I'm going to go this way. What is that value? Right, so I need to think a little bit backwards. So in quadrant 3, right, my angle is, it's a negative value, so it's 180 degrees minus 17.0551 degrees. Negative because I'm going clockwise. So that ends up being negative 163 degrees. So this is a theta value of negative 163 degrees, and that fits our domain right here. This one, 160 degrees, that's my angle in standard position in quadrant 2, 163 degrees. Okay, determine an angle given exact trig ratios. Sine of theta equals square root of 3 over negative square root of 3 over 2 in the domain. Theta is between 0 and 4 pi. Okay, try not to use a calculator. Use the cast rule to determine which quadrant that theta must terminate in. Use your knowledge of the unit circle of special triangles. Determine all angles which satisfy the domain. Okay, either that or a new domain. Check your restricted domain. Do you need to find coterminal angles? Okay. Sine of theta equals negative square root of 3 over 2 in the domain. Theta is between 0 and 4 pi. Okay, so I'm just going to look at it this way. 12 pi over 3. This will help me later, trust me. Okay. Theta r, reference angle first, inverse sine of the absolute value of negative square root of 3 over 2. Okay. What angle can you think of where the sine ratio is negative square root of 3 over 2? What reference angle? Or positive square root of 3 over 2, because we take the absolute value. Well, if I think about it, a y value, the long side of that triangle, that is pi over 3. Okay? Sine of theta is less than 0 in quadrant 3 and quadrant 4. Okay, so let's map it out. In quadrant 3, okay, pi over 3, that's pi over 3. In quadrant 3, my angle in standard position is pi plus pi over 3. That's 3 pi over 3 plus pi over 3. That's 4 pi over 3. So my angle in standard position is 4 pi over 3. Okay, am I within my domain? I am, right? So I still am within my domain for this value. So keep that there, okay? Quadrant 4. Pi over 3 in quadrant 4 is here. This is theta r. How do I find this angle in standard position? So for quadrant 4, I'm going to do 2 pi minus pi over 3, which is 6 pi over 3 minus pi over 3, and that's 5 pi over 3, folks. Okay? 4 pi over 3, 5 pi over 3. Well, I need to find all my angles, right? This little part right here, find coterminal angles. Right now I have 4 pi over 3 and 5 pi over 3. Well, if I add units of 2 pi, right? So if I take 4 pi over 3, add units of 2 pi, but let's make it easy. I'm going to say it's units of 6 pi over 3, right? Because that's the same as 2 pi over 3. That's 10 pi over 3. So there's another solution that falls within this domain, right? That's the maximum there. Okay, and then if I take 5 pi over 3 and add 6 pi over 3, I get 11 pi over 3. And that falls within my domain. If I add 2 pi more here, that's going to be past my domain here. So I'm going to stop. So my 4 solutions, this is one of those that has 4 solutions. 4 pi over 3, 5 pi over 3, 10 pi over 3, 11 pi over 3. So when you're encountering problems like this, and it asks for, solve for sine of theta equals to whatever ratio they give you, and then you have to pay attention to the domain. The domain is super important, because if you miss the domain and you just give the one solution you think is the one that's it, right, you're going to miss other solutions. Okay, so you got to pay attention to this domain here and think about code. All right, folks, continuing. We have the cosecant of theta equals -2 divided by square root of 2. Let's be careful. This is in the domain of theta is greater than -2 pi, but less than pi. So be mindful of that. First off, when we're evaluating the cosecant ratio, we need to think in terms of the reciprocal ratio. So this is related to the sine ratio. So much easier to rewrite this in terms of sine. So sine of theta equals 1 over cosecant of theta. It's the same theta regardless of whether we use 1 over cosecant of theta or sine of theta. And so we know that's the reciprocal. The sine ratio is the reciprocal of the cosecant ratio. So it's negative square root of 2 divided by 2. So I'm taking the reciprocal of this value. Okay, and then it's much easier to work and think in terms of sine ratio. So I'm going to evaluate this for theta. And remember, it's the same theta. Okay, so when we find the angle, it's going to be the angle for the cosecant ratio. Okay, so I need to find the reference angle. So I do the inverse sine of the absolute value of negative square root of 2 over 2. Okay, and then without a calculator, what angle is associated with a positive square root of 2 over 2? Remember the absolute value bars here. Okay, that's pi over 4. That's a reference angle of pi over 4. Okay, but we're also thinking about the sine ratio is less than 0, right? It's negative. It's less than 0, so that's either in quadrant 3 or quadrant 4. Okay, so in quadrant 3, folks, what does it look like? So quadrant 3, my reference angle, all the way over here, theta r equals pi over 4. Well, I got to be careful. The domain is -2 pi to pi, right? So if I use the positive pi value and add it to pi over 4, I'm outside of my domain. So I have to be careful. So I'm going to do this. So theta in quadrant 3, I'm going to negative of the angle, right? So the negative of, and I'm doing pi, if this is pi right here, pi minus pi over 4, and that will give me the negative value of this angle that stays within my domain. So I go theta equals negative, that's 4 pi over 4 minus pi over 4, and theta equals negative 3 pi over 4. Okay, so that's in quadrant 3. Quadrant 4, well, here's my reference angle. Theta r equals pi over 4. Okay, how will I stay within my my domain, right? So if I do a positive angle, I'm going to do 2 pi minus pi over 4. Let me just show you this. Don't write this down. If I do positive angle, it's 2 pi minus pi over 4. Well, is that outside of domain? That's 8 pi over 4 minus pi over 4. That's 7 pi over 4. That is outside of my domain, folks. Remember, I have a maximum positive pi value, so I can't do this, right? So we need to think in terms of negative angles. So this is really going to stretch your knowledge here and understand, how do I think of this in terms of negative angles? Well, this pi over 4, if I start from an initial arm and I go clockwise because it's a negative angle, theta equals theta r, the angle in standard position is just a negative pi over 4 since I'm going clockwise. Okay, so my solutions are theta equals negative 3 pi over 4 and theta equals negative pi over 4. Okay, next page. Sine of theta equals 0 in the domain, negative 180 degrees to 180 degrees. Okay, so same thing. We start off reference angle equals this inverse sine of the absolute value of 0. Reference angle is 0 degrees, so where is sine equal to 0? Well, at 0 degrees within this domain, right? So positive 180, negative 180. Okay, notice it says it's not equal to 180 itself, so it's just 0. Sorry, the reference angle is 0. Okay, so sine of theta is greater than 0, so this is quadrant 1, quadrant 2. So let's look at quadrant 1. Sine, the reference angle is 0. Okay, so theta r equals theta, angle in standard position, equals 0 degrees. Okay, this is in quadrant 1. Okay, quadrant 2. Okay, quadrant 2, sine of theta is 0. Okay, folks, there's an error in the notes here, so hopefully by the time you see this in class we'll correct it. This sine should be a less than or equal to. Okay, so fix that please. 180 degrees, negative 180 is less than, theta is less than or equal to 180 degrees. Okay, otherwise this quadrant 2 solution doesn't work. Okay, so quadrant 2, theta reference angle is 0. So how do I find the angle in standard position? That's 180 degrees minus 0 degrees. That's 180 degrees. So your solutions are 180 degrees. That 180 fits in the domain because it's equal to it or less than it, and then the 0 also fits within this domain. Okay. Okay, you try. So pause it here, give this a try, and then come back to it. Okay, determine all angles for a tangent of theta equals 1 over square root of 3 in the domain, negative 360 to positive 360. Okay, so let me rationalize this denominator. Okay, so there it is. Let's find the reference angle. So the inverse tangent of the absolute value of square root of 3 over 3. Okay, that one you should be able to do by your head, not using a calculator. So we should get in degrees a reference angle of 30 degrees. Tangent of theta is greater than 0. That's either quadrant 3 or quadrant 1. Cast rule. Okay, remember C-A-S-T. Okay, so quadrant 1. Theta r 30 degrees. Okay, so this one's easy in quadrant 1. So quadrant 1, that's theta equals theta r equals 30 degrees. So that's my angle in standard position. Quadrant 3, so 30 degrees, reference angle. What's my angle in standard position? Well, I need to start from my initial arm, sweep all the way through. So it's angle in standard position equals 180 degrees plus 30 degrees. That's 210 degrees. Okay, but are we done? Look at my domain here. Negative 360, positive 360. Okay, let's circle these. So that's one solution, two solutions. Let's look for coterminal angles, right? So if I do 30 minus 360, 30 degrees minus 360 degrees, that's negative 330 degrees. That's another solution. That's within my domain, okay? If I go more negative, it's going to be outside of my domain, so I'm done there, okay? So if I do 30 plus 360, that will not work, will it? Yeah, 30 plus 360, that's outside of my domain. So if I do, let's do this, 210 degrees minus 360, I get negative 150 degrees. That is definitely within my domain, okay? If I do 210 plus 360, that goes outside of my domain. So these are my four solutions. So you always have to think of coterminal angles when we are minding a domain that is different, right? It's not always the same domain. Okay, last one. How do you find a missing angle if you're only given a coordinate point? Okay, let's try this. The point -5, -2 lies on the terminal arm of an angle theta in standard position. Determine angle theta to the nearest hundredth of a radian in the domain. Theta is an element of -3 pi over 2 and 7 pi over 2. Okay. Okay, if I map this out, folks. 1, 2, 3, 4, -5, -2. That's my point right there. Okay. That's clearly in quadrant 3. Okay, what is this angle in standard position? We're asking this value, right? But before we do that, let's find out this reference angle right here. So let's draw our triangle. Here's theta r. Okay, if I pull this triangle out, what does it look like? Here's theta r. This is -5. This is -2. Okay, so from this one, I can think of the tangent ratio. So the tangent of theta r equals opposite over adjacent, -5 over -2 over -5. When I look for the reference angle, I'm taking the inverse tangent. And remember, I do the absolute value because I'm looking for the reference angle. Always calculate the reference angle first. So this is in radians, right? Radians. Okay, calculator should be in radian mode. This one I get a radian value of 0.380506. Okay, so now that I in quadrant 3, I know it is an angle in standard position equals pi radians plus 0.380506, which is my theta r reference angle, sorry. Okay, so theta equals to 100th of a radian, 3.52 radians. Okay, not done yet though. Look at our domain. We have to mind our domain. Is that all of the solutions within my domain? Okay, let's take a look. Coterminal angles. If I take 3.52 radians and I subtract a full rotation 2 pi, I get negative 2.76 radians. Okay, those exact values in radians up here, let's just bookmark those, right? So what do we got here? That is 3 pi divided by 2, negative 3 pi divided by 2, that's roughly negative 4.71 radians, bounded by 7 pi over 2. 7 pi over 2, that's 10.99 radians. Okay, so let's keep that in mind when we're doing our coterminal angles. Negative 2.76. If I add more negative, if I subtract another negative 2 radians, negative 2 pi radians from this, I'm outside of my boundary, right? So that's one solution. This is my first one. That's my second one. And then let's go more positive. So if I take 3.52 radians and I add 2 pi radians, I get 9.80 radians. That is well within my positive boundary for the domain. If I add another 2 pi radians to this, I'm outside of my boundary. So what are my solutions? Negative 2 point, says to the nearest hundredth. So, sorry, negative 2.76 radians, 3.52 radians, and 9.80 radians.